These next few properties are just absolutely crucial to being able to work with logarithms. And I know that a lot of times I see students who are studying for like their pharmacy entrance exam or their medical school entrance exam, and they have to come back and review their properties of logs because there's actually a lot of that on the PCAT and the MCAT. So it would be worthwhile to really pay attention and understand them at this juncture so that you use them later on. Okay, our first one says the log of a product equals the sum of the logs. So here we have log base A of m times n is equal to log base A of m plus log base A of n. Basically, this says that if, and you can go backwards and forwards, if you've got two logs that are separated by a plus sign, we could put those arguments back together using multiplication. Now, the opposite of that, the opposite of addition would be subtraction. The opposite of multiplication would be division. So those things go together also. This one says if you've got the log base A of m divided by n, that equals the log base A of m minus the log base A of n. So if we have two logs, they have to have the same base. But if you are subtracting two logs, we could put their arguments back together using division. This is a way that we can either separate them out if we need to, or we could put them together as a single logarithm if we needed to. Very valuable depending on the situation. This last one here on this page says log base A of m to the r power equals r log base A of m. Now let's just look at an example so you can see why that is. Let's pretend like I have a log base 2 of 6 squared. So I've got, and maybe even I should do another one so that we don't not using the same numbers, 6 to the third power. Okay, what does it mean to multiply something to the third power? It means to multiply to itself 3 times, right? So this would be the same thing as saying log base 2 of 6 times 6 times 6. True? Okay, now we have a property that says if we've got logs that we're multiplying, we can separate them out with addition. So I could separate these out and say log base 2 of 6 plus log base 2 of 6 plus log base 2 of 6. Now, how many of those same logs do we have? There are 3 of them. So that's the same thing as saying 3 of those log base 2 of 6's. Now, what I could have done using this property, though, this is a kind of a shortcut, is I could have said the exponent drops right down in front of the log, and I could have written that as 3 log base 2 of 6 and bypassed this work. So this is just a shortcut to actually an already existing property. So again, the things that you have to know here, you must know that you can separate out logs. If they're multiplied, you can separate them out with addition, or vice versa. If they're separated with addition, you can put them back together with multiplication. If logs are put together with division, we can separate them out with subtraction, or vice versa. If logs are separated with subtraction, we can put them back together with division. And then a shortcut is that if we have an exponent, we can take and drop that right down in front of the log and make it a product rather than a power.